Good evening, everyone. Okay, is there anyone who is joining for the first time? Or have you guys attended the previous sessions?
Yes, sir.
Okay. Any queries from the previous sessions? And how are you finding assignments? Like, are you facing any difficulties which you would like to discuss? Okay, fine. So please let me know whatever queries you have. Actually, we are running 1 week behind the schedule. So in the last week we covered. So let us just go to the slides. So in the previous week, we covered certain topics, including distributions, which had discrete and continuous distributions. In discrete distribution, we saw binomial, Poisson, and hypergeometric, and in continuous, uniform, exponential, and normal. And we saw some problems on these distributions and some Python programs. So if you have missed that class or session, that please visit the YouTube recording and get those things clarified. And if you don't get anything in that, please feel free to ask during one of these sessions. Then after that, we saw sampling and sampling distributions. Like, why do we need sampling? Like, what is descriptive statistics and what is inferential statistics? And then why do we need sampling and different types of samplings, in which we saw random and non-random samplings. And then after that, we kind of touched upon the concepts like distribution of sample mean, and we briefly discussed point estimate and confidence interval. So are there any queries in these concepts? We'll discuss it further in this class. Okay, so can anyone tell what is point estimate and what is confidence interval? First of all, what is an estimate, basically? Feel free to answer in chat, like you need not unmute yourself and answer. Otherwise these sessions get boring, like it will be like just a one way interaction. And uh, yeah, so even if you answer wrong, that's fine, but please do answer. Like, what is an estimate? Anyone? Okay, so let me quickly tell you. So there are two types of estimate. Estimate is nothing but like inferring some value of the population from the sample. Okay, so there are two types of estimates. One is point estimate and the other one is interval estimate. So what do you mean by point estimate? The point estimate is like a single observed numerical value used to estimate an unknown population parameter. So say you take a sample. You have a population of say multiple like all the people in the country, and each one is having certain height. So you want to measure the average height of the people. So you cannot do that. So you take a sample out of the population, and then you estimate the mean of the population. Sorry, mean of the estimate the mean of the population using the sample statistic. So you estimate the mean of the sample, you compute the mean of the sample, and that mean of the sample is the point estimate of your population sample, which may not always be correct, right? So say you have like 10 people, say population is only 10, and each one is having different heights. Some people are having lower heights and some people are having higher heights. So when you do sampling, say you just end up doing sampling of people with lower like low heights, and you compute the mean of that. So the estimate, like the mean, will be also having a pretty low value, and which is not a representative of the average of the entire population. So let me quickly show you with an example. Just a second. Okay, are you able to see my screen? Is my screen visible to everyone?
Yes.
Okay, thanks. Okay, so what we were discussing, say you have like population is like this. These are the heights of people, and you end up taking this sample from the population. So the mean will be around this, right? Mean of these three values will be around this, which is not the actual mean of the population. Actual mean will be somewhere around this. So to tackle this problem, we say that we want certain confidence, or like certain interval in which the actual population parameter may lie. Okay, so you have the point estimate and you have the confidence interval based on which you can, or you say like with certain level of confidence you want to estimate this interval. So based on that you get this interval value, and that interval is nothing but, now what is z and what is this sigma by root n, we will look into it in detail. So is there any query till now? Okay, fine. I assume that it is clear to everyone, and we'll quickly move on to the hypothesis testing then. Okay, is my screen visible? Thanks. Fine. So let us see hypothesis testing. What is an hypothesis testing? Like what is hypothesis testing basically? Can anyone answer? Anyone? Please do try to answer. Yeah, it's the sessions are meant for you, so you should be like able to kind of like answer what, if you, even if it is wrong, please try to answer. Testing with or without considering actual parameter. Uh, Not really, means like close to it, but what about others? Like, can you try answering? What is, why do we need hypothesis testing, and what is an hypothesis, by the way? Okay, so say you have a problem at hand. Say we are working in a factory milk production, or like a milk factory which is producing, like which is filling out bottles of milk. Okay, so each bottle has a capacity of 500 ml around. So the milk is being filled and you have like around 1 lakh milk bottles. So my claim is that the milk bottles contain 500 ml of milk. Okay, let me explain it here. Say there are 1 lakh milk bottles and your claim is that, or what is claimed that by the factory, that every bottle contains an average of 500 ml milk. Now you end up taking certain sample, or say 50 bottles or say 30 bottles out of these 1 lakh bottles, and then you compute the mean of that, that is sample statistic. This is the population parameter. 500 ml is the average quantity of milk claimed by the manufacturer, and you take a sample out of it and then you compute the sample statistic or mean, and you found that like the mean of the, or the average amount of milk present in the bottles is 502 ml or something like that. So your alternate hypothesis, so your null, so we will have two hypotheses in the hypothesis testing. One is null hypothesis, which says the mean of the population is 500 ml, and your alternate hypothesis will be, in this case, mean not equal to 500 ml. Okay, so we have got two hypotheses. Now to test whether this alternate hypothesis is correct or whether we can reject the null hypothesis or not, for that we do hypothesis testing. Is that clear to everyone? And the null and the alternate hypothesis, these two hypotheses, they depend on the problem at hand. Like in this case it was equal, like the mean of the population was considered, like the quantity was given by the factory, and then the alternate hypothesis was it is not equal to the value given by the factory. It can be greater than or equal to, but in certain cases it depends, like whether the alternate the null hypothesis is greater than equal to certain value, say mu is greater than equal to mu naught, or mu less than equal to mu naught, or mu equal to mu naught. So depending on the problem at hand, we will have to define the null hypothesis, and then accordingly the alternate hypothesis. So in this case alternate hypothesis will be mean greater than mu less than mu naught. In this case it will be mean greater than mu naught, and in this case will be mean not equal to mu naught, which also implies mean less than mu naught or and mean greater than mu naught. Okay, so we will see some examples, and based on that we will clarify your queries. So hypothesis testing is nothing but a method of statistical inference used to decide whether the data that you have in hand sufficiently support a particular hypothesis or not. So the very first step in any hypothesis testing is the calculation of test statistic. in this case, like as in the example of milk bottles we saw, the test statistic was the average of the mean, average of the quantity of milk in the bottles or in the samples that we have taken. Again, it depends on the problem at hand and what kind of tests you are doing. Once you have the test statistic, then you make a decision whether to accept the null hypothesis or not using three approaches. Like one of the three approaches, there are three approaches. One is critical value. Okay, let me share the screen again. Okay, we'll see what this one tail, two tail tests are. So there are three approaches to do hypothesis testing. One is p-value approach, other is critical value approach, and then the third one is confidence interval approach. So we'll look into all this in detail. Okay, so let us move ahead and see some questions. There are not many questions today, or we may end up terminating this session earlier. So let us quickly go over this concepts and then we'll see some Python programs. So first is this is what already we have answered. So why do we need confidence interval? To account for variability in our estimates, because point estimates are not always reliable. Your sample may not be representative of the population, so you take this confidence interval into consideration, in which your population parameter may lie. Okay, so which one is not an approach for hypothesis testing? We just saw quickly answer. P-value, critical value, confidence interval, and interquartile range. Okay, that was straightforward. I'm sorry, like those of you who are feeling it very basic, I want to cover from the basic. Like there are other TS who will be covering the advanced level things. So yeah, please feel free to join those sessions as well. We will definitely be covering the advanced level concepts later in the course or later in these sessions. But yeah, I want to cover the basic ones first and then move on to the advanced ones, where we will do a lot of programming. Okay. So and for those like who are feeling it very basic, like attendance is not mandatory. So you may it's up to you if you want to attend these sessions. Please feel free to leave like whenever you feel like, and you can definitely look at the recording. So all these sessions are getting recorded, and I'll be uploading the link to my recordings, like session recordings, to my YouTube channel. So let me just put the link to the YouTube channel over here in chat box. Okay, so whenever you can look at these recordings at your own pace. Maybe if you are feeling it is quite slow, you can watch the recordings in 2x and accordingly decide. Okay, fine. So in the last class we saw two concepts: distribution of sample mean and point estimate confidence interval. So let me share my iPad screen again. Okay, so we had certain population, we took sample, we took the mean of that sample, and our statistic was the mean of the samples. We take another sample and they take the mean of it, take another sample, take mean of it, take another sample, take mean of it, and so on. Okay, so after you take the mean values, you kind of put a probability distribution on top of it. No matter what the nature of this distribution of the population, we found that the distribution of the sample means request everyone to please keep their videos off. Yeah, so the distribution of the sample mean will always be normal. Okay, this is what we saw in the previous session, and we saw some animation for that as well. I'm sorry, like I was not, I think somebody asked for the link, I could not share it in the chat. I'll definitely put that in the video description for this particular session. Okay, so taking this information into consideration, now we compute Z statistic, like depending on the problem at hand, we'll compute certain statistics on which we'll decide whether to reject null hypothesis or not. Okay, let me see like what all I can skip for now, and then fine. So let us see this problem. The mean response times for a random sample of 30 pizza deliveries is 32 minutes. Any queries? Week 4 topics regarding errors, distribution and confidence interval. Nikhil,
Yes, week 4 topics like from the course I meant.
oh, course means like week 4 topics in the sense, okay, let
Yeah,
me just go.
from the yeah, errors and confidence intervals.
Okay, so yeah, we'll come to that,
Yeah, sure,
Nikhil.
sure,
Yeah,
sure, sure.
yeah. Okay, we'll see this example, and relating to that, we'll see the concepts that are to be covered. Okay, so the mean response times for a random sample of 30 pizza deliveries is 32 minutes. The population standard deviation is believed to be 10 minutes. The pizza delivery services director wants to perform a hypothesis test with alpha equal to 0.05 level of significance to determine whether the service goal of 30 minutes or less is being achieved. So solve using p-value approach. Now we have not discussed all these things, but I wanted to take this example and then like delve deep into the concepts. The first thing into any hypothesis testing problem is to identify the null and the alternate hypothesis. So what will be the null hypothesis in this case? Anyone? Okay, 30 pizza, but what is that 30 pizza? The mean standard deviation also.
Mu less than or equal to 30 is the null hypothesis.
Yes, so you will have to be very clear about the units. So it's 30 minutes. So the null
Yeah.
hypothesis over here is the mean delivery time is less than equal to 30 minutes, and the alternate hypothesis will definitely be the mean delivery time is greater than 30. So just a second. Our mean delivery time, the null hypothesis in this case is, mean delivery time less than equal to 30, and the alternate hypothesis is mean greater than 30. Now based on the data given to us, we have to decide whether to reject this null hypothesis or not. So what is the data given to us? Let me put this question in chat for you to refer to. Okay. the population standard deviation is believed to be 10 minutes. So we have been given sigma. The first statement I missed out. The mean response time for a random sample of 30 pizza deliveries is 32 minutes. So the sample given is of 32 pizza deliveries. So sample size is 32. The mean of the sample, that is the
X
sample.
bar is equal to 32.
Oh, sorry. Sample size is 30 and X
X
bar
bar
is
is 32.
32. Yeah, thanks Nikhil for pointing that out. And the population standard deviation is given. In many of the cases, this population standard deviation may not be given to you. In that case, you will see what you can do. But in this case, we have this population standard deviation given to us.
When not given, should we use t-test?
Yes, definitely. We'll come to t-test. So what we are going to do right now is z-test. So if the null hypothesis is true, then this statistic, which is also called as z statistic, computed as x bar minus mu upon sigma by root n, will have a standard normal distribution. Now what is a standard normal distribution? Standard normal distribution is a normal distribution with mean 0 and standard deviation. Anyone?
1.
Yes. Okay. So if this statement is true, then this statistic will follow a standard normal distribution, and then we have to decide based on this and the sample that we have whether we can by the way, one more thing. So in this case, you will have to note that there is this so the distribution
Is
of
it
the
only sigma?
yeah, so it will be sigma by root n actually. So in this case, actually we are taking the distribution of the sample means. So okay, let us avoid this, it's creating confusion. Okay, so here there are certain concepts involved. So this sigma by root n, so generally z value is computed as x bar minus mu by sigma for any random, so it's like you are taking certain values x is a random variable, and then you are transferring it to a distribution which is having mean mu and standard deviation sigma. In this case, what you are doing over here is you are transferring it to a distribution in which is having the mean value of sorry, what will be this thing? Can anyone answer? Okay, say let me have a distribution over here. It is having mean 30. So if I do 30 minus, if I shift the mean by say 20, so what will be the new mean for that? I'm sorry if I am making you confused, like anyone, can you please answer? Like if I am shifting this distribution by 20, so what will be the new mean?
Mean, does it mean remain the same?
No, you are changing the shifting the mean, right? You are transforming the mean.
Shall we add this 20 to it?
So you are no. So if you are subtracting mean. Okay, let me see if I can show you it. Show it to you visually. I hope my screen is visible. Is my screen visible to everyone? Fine. I assume it is visible. So this is a normal distribution with mean 0 and standard deviation 1. If you change the standard deviation, you see that the curve is becoming flatter. Okay, now if you shift the mean, say the mean is 20, do you see what is changing over here? Is it clear?
Sayesh, can you please explain one more time?
Okay, let me see if any other tool I can use. Okay, so basically what is happening, you have a normal distribution. When you subtract when you subtract for any function in general, when you subtract certain value out of it, sorry, it's very difficult to explain it over here. Let me just try GeoGebra. Okay, so you have this function y equal to x. Now what will the function y equal to x plus 1? Do you see that this particular function got shifted by 1 on the negative side?
Are you showing some
Oh,
changes over here?
oops,
Oh, yeah.
sorry, sorry,
Okay.
sorry,
It's a Desmos?
sorry,
Okay.
my bad.
Fine.
Yeah, so this is
GeoGebra.
GeoGebra. Yeah, so I plotted this line y equal to x, and say I plot y equal to x plus 1. So you see that the function got shifted by 1 on the negative side.
One. Yeah.
If I do y equal to x minus 1, the function got shifted by negative 1 on the other side. Sorry, 1 on the other side,
On
positive
the other
side.
side, yeah.
Yeah,
Plus one.
yes. Similarly, let me see if I can plot normal distribution over here. I'm not very sure. Okay, can you see this?
Yeah. How did you do that?
Okay,
You just write the function?
yeah, so I have written a function over here. Let me just normalize
Hmm.
it as well. 1 upon. Okay, so let me zoom it in. Okay, can you see this normal distribution over here? So
Yes.
it is 1 upon root 2 pi. So it should be actually root 2 pi. Okay. So 1 upon root 2 pi sigma square, in this case I am taking standard deviation as 1, e to the power minus x minus mu square upon sigma square, where mean is 2 and standard deviation is 1. Fine. Is that clear?
Yeah, the function is clear.
Yeah. Say now if I shift the mean, like add something to the mean. So the current mean is 2 and let me add 1 to it. So what will happen? The mean will get shifted to 3, right? Similarly, if I subtract something from here, so the mean will get shifted accordingly. Similarly, okay, so that's what is happening. Now if I divide it by a certain value, say my standard deviation is 2, so 2 square is 4 over here. So you can see the shape of the distribution also got changed. Fine. So this was just to give you an idea of what is happening when you are computing that sample statistic z, x minus mu by sigma by root n. So you are kind of like transforming the original normal distribution of sample mean to some other space which is having mean mu and standard deviation sigma by root n. Okay.
I have a question over here, Saish.
Yes.
Whatever we have studied till week 5, it's more focused on statistics.
Yes.
Uh, it's like, less of the using of the same thing in the Python.
I see. So you want to have more problems on Python, is it?
Yeah, because by the name of the topic is data
Yeah.
analytics.
Yeah. So I basically, like for anything, like whether it be statistics or any other topics like machine learning, the first thing that you need to cover up is the basic
Theory,
mathematics, yeah,
basically.
theory,
Yes.
and then apply it. For example, in the case of machine learning, there are two things that are very important. First is linear algebra, and the second is probability theory. So
Okay.
yeah, so unless you get a hold of these two uh, subjects, it will be very difficult for you to code yourself the machine learning algorithms.
I got it.
Yeah.
So, are we expecting more of the practical things, how to use
Yeah.
the
So
data,
yeah,
all
yeah.
these things in the
Yeah,
upcoming weeks?
definitely we'll look into that, but it will be like theory plus the Python programming in this course.
Yeah, that's what we want.
Yeah, so we'll be also looking at, so we'll solve this particular problem using Python as well, and we'll try to see if we can just solve other problems as well. Like uh, I'm not sure if I'll be able to cover ANOVA and other things, but yeah, we'll see the basic sample or like hypothesis testing today in Python as well.
Oh, that's great.
Yeah.
Okay.
Okay. Okay, let me share
So,
my
have we
screen.
solved this question?
Yeah, just a second.
And the questions in the exams will be similar to this?
Not really. Like it will be similar to what you get in the assignment, like MCQ type questions, mostly.
Okay.
Yeah.
Yeah, I just wanted to ask one thing. Actually, the score tables, Z score and T score, these
Yes.
tables will be provided during the examination, or the values will be given?
Mostly they might provide. I'm not very sure if they will be providing the Z table or T table, but yeah, if you are needed to calculate some value, they will either provide it online, or you may have to, like, they'll provide it like a printed version of it. I'm not very sure.
Actually, while the queries that are asked through the Swayam portal, they have told that they'll provide Z table and T table in the exam
I
hall.
see. Okay. Yeah, great. So yeah, I
Okay,
hope that
hard copy will be provided.
mostly yes. I'm not very sure.
Yeah, yeah.
Okay, okay.
Okay, great.
Oh, yeah.
Okay. So what we were doing, our sample mean was having certain distribution, and it should be close to the population mean. The mean of the sample mean should be close to the population mean. Is this concept clear to everyone? Like last time we saw, we had population values, and we took samples, and for each sample we took a mean value, and so on, and we generated a distribution out of it. That is nothing but distribution of sample means. And if you see the mean of this distribution of sample mean, it will be close to the actual population mean. Fine. So now you have this distribution, and and it is also given that the standard deviation is also given in the problem at hand. So the mean value is given as 30, population mean, and the sample deviation is given as 10 minutes. Now what is given to you is, you have taken a sample, and the average of that particular sample, like 32 deliveries were taken into consideration, and the average of that particular 32 deliveries was 32 minutes, which will lie somewhere, say, over here, x bar. So now based on this, you will have to decide whether this hypothesis, null hypothesis, which says that the mean delivery will be less than or equal to 30 minutes, if it is acceptable or not. Our alternate hypothesis is it is greater than 30, and we have been given the sample size of 30, whose mean is 32 minutes. Fine, which will lie somewhere over here. So the first step that we do is we compute this z statistic. Since the sigma is known, so there are two cases: sigma known and sigma, that is the population standard deviation, unknown. So when this is known and the sample size is greater than or equal to 30, you tend to perform z test. Similarly, when sample size is more than 30 and sigma is unknown, ideally you should be performing t test, but okay, for those who do not know what t test and t distribution, so this name z and t come from the distributions. So z stands for z distribution, which is nothing but normal distribution, and t stands for t distribution or student t distribution. So both are different distributions, but if you see this z distribution, the normal distribution is having two parameters, mean and the standard deviation, and the t distribution actually has this parameter called okay, let me show you quickly how t distribution and z distribution look like. Okay, So do you see this difference over here? The shape is almost similar for the t distribution. It is almost same as the normal distribution, but the difference over here is, if you see at the tail end, the tail will be like somewhat higher, having higher value compared to the normal distribution tail. You can see this is normal distribution and this is t distribution with certain degrees of freedom. Okay, so what is degree of freedom in statistics? Can anyone answer?
It is something related to choice to choose, like.
Yes, exactly. So degree of freedom are like the values you can change, like the choices you have for the values. So like if the degree of distribution, degree of freedom is say 5 for a given distribution, so you can change values in 5 directions. For example, say we have, so you would have come across this term sample standard deviation, right? So to compute sample standard deviation, what is the formula? Say you have sample
In denominator, we use n-1.
yes, so there you use n-1 because you have n-1 degrees of freedom. Okay, let me explain it to you. So when we compute a sample standard deviation, so we divide by n-1. What is the reason? Can anyone explain the reason behind it? If you are computing population standard deviation, so this is variance. So we take the denominator over here as n and over here it is n-1. The reason being, here you are computing this x, right, using the sample values. Say x is x1, x2 up to xn. So x bar is given as x1 plus x2 and so on up to xn divided by n. Fine. So this is fixed, this value is fixed. So now to get this same value, I can change n-1 values and keep the other one value constant. This value is fixed now, right? Is it clear to everyone, like what is happening here? If I fix one value over here, I can change the other n-1 values to get the same x bar. Is that clear?
Kind of.
Okay, it's difficult to explain this. Okay, so if I have, say, let me say like this, if I have the mean and if I have the n-1 data points, can I find the nth data point using that?
Yes.
Right. Bhumi, you have any query? Yeah. So here, given this n-1 data point and the mean, you can find the nth data point. So you can change these n minus 1 values, the mean will remain constant. You can change the n minus 1 value, but the value of this nth term will be dependent on this n minus 1 values and the mean. Okay, so you are restricting this nth value once you fix the mean, and like once you have the fixed value of the mean and you have n minus 1 values, the value of the nth sample will be fixed. So you have only n minus 1 options that can be changed. Yes, Bhumi, you have any query? So the degree of freedom in this case is n minus 1. Sorry if it is not very clear. I would urge everyone to please go back and then see what like degrees of freedom in detail. So we'll quickly see the example over here. So T distribution is having this parameter called degrees of freedom. Like every T distribution is having this degrees of freedom, which will decide the shape of the T distribution. It is also called as student T distribution. So let me just show you. So based on the degree of freedom, the shape of this particular distribution will change. Okay. So coming back to our discussion, when we know the population parameter, the standard deviation, and the number of samples, the sample size is greater than or equal to 30, in that case we use z-test. If it is less than 30, still we use z-test. If sigma is unknown and the sample size is less than 30, in that case we use t-test. Here ideally we should be using t-test, but in this particular course, Professor Ramesh has suggested that you can also use z-test. The reason being, as you increase the value of n, so the degree of freedom for T distribution will be n minus 1. Somebody is on request everyone to please be on mute. Okay, so the degree of freedom for this T distribution will be n minus 1, and as you keep on increasing the value of n, the T distribution will tend towards the normal distribution. Now how is that possible? So I'll request everyone to please go back and see, like I try to see like how to plot T distribution in Python, and then try changing the value of the degrees of freedom. Okay. So as you increase the value of n beyond 30, it tends towards normal distribution. So it is okay to make an assumption that the distribution is approximately normal, and hence Professor Ramesh suggested that if the sample size is more than 30 and sigma is unknown, so in that case you can use z-test. Okay, so what are these z-test and t-test? So in z-test, we compute the statistic called z statistic, which is defined as sigma by mu, sorry, x bar minus mu upon sigma by root n. So this is the mean of the population. This is the standard deviation of the population, and n is the sample size. Okay, so in our problem, we were having the mean population mean as 30, population standard deviation was given as 10, we computed the test like we had this test statistic x bar as 32. So, the z value will be 32 minus 30 upon 10 by root 32. Now, I have this z distribution with mean 0, and then the computed z value is 32. Okay, sorry. What will be this value? 32 minus 30 upon 10 by root 32. Sorry, am I making any mistake over here? 30. So, it is 30. The sample size is 30. Okay. Now, what is the probability of z greater than equal to certain value z naught for this z distribution, which is nothing but a normal distribution. So, how will you compute this probability? Say I have this distribution, normal distribution, and there is this value called z naught. So, I want to compute the probability that z is greater than equal to z naught. So, what will be that value, particular value? How will we compute that?
Do we look up in the Z table?
Okay, z table, but what does the z table give you? What value does it give? In terms of area, what area will it be?
The area
Greater than Z
right
naught.
of Z0.
Right hand side of the Z naught.
Yes. So, this particular area will give you the probability of z greater than equal to z naught, where z naught is certain value or statistic, that test statistic that you have computed. Fine. Now, there is a concept of significance. So, before going to the significance level, we will discuss two other concepts. Okay, Nikhil, are you there? You had this query, right? The errors. So, there are two types of errors, type 1 error and type 2 error. So, type 1 error is the error in which you reject the null hypothesis when it is true. And type 2 error is you fail to reject null hypothesis when H naught is false. Okay. So, in this case we had this null hypothesis that the mean delivery time is less than equal to 30, and alternate hypothesis was mean greater than 30. So, if this is true and you are rejecting that particular null hypothesis, so you are making a type 1 error. So, there will be certain probability associated with that, like what is the probability of making null like rejecting null hypothesis, and for that we define a term called significance level. which is also known as alpha, which is probability of rejecting null hypothesis H naught. So, in the case of this distribution, we had this distribution over sample means, that is x bar, and we transformed it to a space x bar minus mu upon sigma by root n. So, this particular distribution is z distribution, and this particular value will lie somewhere over here. It may lie here as well or somewhere, anywhere. So, now you have this concept of alpha. So, what alpha denotes? It is the probability by which you can reject the null hypothesis. Now, it depends on the nature of the null hypothesis. So, if the null hypothesis is like mu1 equal to 50, so it means that the alternate hypothesis will be mu greater than 50 and less than 50. Okay. So, the problem at hand, it can be mu less than equal to 50, alternate hypothesis can be mu greater than 50. So, depending on this, we will decide if we want to do a two-tail test or a one-tail test. Now, what is one-tail test and what is two-tail test? So, one-tail test will be where the probability of rejecting the null hypothesis is towards one of the tails of the distribution. For example, in this case, mu greater than equal to 50. So, I will be having a value of 50 and I want to see, I will be having certain probability value or certain statistic, based on which I will have to decide whether this hypothesis is true or not. Say I am getting some certain value x and I am getting the probability of x bar being greater than equal to certain value. So, this will be my area under the curve, and then I have also been given the value of alpha, that is the significance level, which is generally taken as 0.05 in literature. So, if the area under this curve is less than alpha, the area under the curve is being computed using Z statistic. We will see that how it is done. If this area under the curve is less than this alpha, then we say that we reject the null hypothesis based on the statistics that we have. If the null, alternate hypothesis were like this and the null hypothesis like this, so in this case we take other tail test like the left tail test. This is known as upper tail test, this is known as lower tail test. And if the null hypothesis itself is like having equality, strict equality, and alternate hypothesis is having 50, greater than 50, less than 50, and so on, in that case we take two tail test, but the value of alpha here, the area over here will be alpha by 2, and here as well alpha by 2. So, based on our statistic value and the significance level, which is nothing but the probability of rejecting null hypothesis. So, based on these values we will decide whether we will reject our null hypothesis or not. So, let us go back to this is like on a superficial level. Let us see this problem and then you will get a better clarity. I'll go to Python maybe and then explain it over there. Okay, is my screen visible to everyone?
Yes, it's visible.
Yes, it is visible.
Yeah. So in this case, we will be using this SciPy library, which is having all the distributions. So SciPy is a library from which we are importing this module called stats, and stats has multiple distributions. So in the previous weeks, we saw different distributions like binomial, Poisson, hypergeometric, and normal, uniform, and exponential distributions. So all these distributions are present in this scipy.stats module, and you can access them using the function that is defined for that particular distribution. So for the normal distribution, we have this function called, or the submodule called norm in the scipy.stats library. So stats.norm.cdf will give you the cumulative distribution function. So what is a cumulative distribution function? Say I have this normal distribution. So cumulative distribution function will be the area under the curve, or the probability of the random variable which is having this normal distribution less than equal to certain value. Say in this case the random variable is z, and what is the probability of z being less than equal to -1. So this will be the area under this curve till here. So this will be my cumulative distribution function in the case of continuous distributions like normal distribution. In the case of discrete distributions like binomial distribution and all, it will be basically the sum of the probability values, the discrete probability values that we have. So what we are doing over here, stats.norm.cdf till -1.46. So if you just do till 0, what will be the value? Can anyone tell? Stats.norm.cdf of 0. Anyone?
50%, yes.
Okay, what will be the value of this? Stats.norm.cdf 0.
.5.
Yes, exactly. So it is nothing but you are taking 0 till 0, you are finding the area of this particular region, which is nothing but 0.5. How? Because the area of the entire curve is 1, area under the curve, and it is symmetric in nature. So it will be 0.5 plus 0.5. Okay. So this was about cumulative distribution function. Now say you have certain alpha value, which is our significance level or the probability of rejecting null hypothesis. Here in this case we have taken it as 10%. In literature it is taken as 0.5, 0.05 in general, or 0.01. 0.5 is the most frequently used alpha value. So stats.norm.ppf. So ppf is nothing but percent point function or inverse CDF. So say you have been given this area under the curve till here. Given this area, what will be the z value over here? To compute that, you use this percent point function. Okay, so you have this alpha. Alpha is given to you. Say, let me say 0.5. So what will be stats.norm.ppf of alpha? Anyone?
This must be 0.
Yes. So this is 0. Okay. So now let me go back to iPad. You have the distribution. Say you have some value z over here. So stats dot norm dot CDF of z will give you the area under the curve till this particular z value. Okay. So if I want to find area under the curve of this region, so what will be this blue area?
One minus stats.norm.cdf of z.
Okay. Is everyone getting this? Please ask me, like, if it is not clear to you, I'll explain it again. Yeah, so that's correct. Yes, Abhinaya, you have any query? Fine. So how is this? So the area under the curve, this curve is 1. So what we are doing over here is this particular area plus this blue area will be 1. So this blue area will be 1 minus the red area, and red area is nothing but your stats dot norm dot CDF or the cumulative distribution function till z. Okay. So you have this at hand, this function at hand. Based on that, you can compute the area towards the right if you are doing right tail test. If you are doing left tail test, you can simply compute the CDF over there. Is that clear to everyone? If it is not, please let me know, I'll explain it again. Okay, I am assuming that it is clear to you. So let us go back to the Python notebook. Okay. So 1 minus stats.norm.cdf will give me the area to the right side of the value 2.29 in the standard normal distribution. Okay. So getting z alpha for lower tail test, given the alpha value, it will be stats.norm.ppf alpha. Okay, let me again go back to iPad and quickly explain this. Say you have been given this area and you want to find out what is the value of this z. This area is A, suppose. Oops, sorry. So this area is given to you, red color area, and you want to find out the z value. So for that, you use stats.norm.ppf. of the area. So, you will have to clearly see that the input to this PPF function or percent point function is the area under the curve, and the input to the cumulative distribution function is your z value. Okay. Given the z value, what is the area under the curve is given by a CDF, and given the area under the curve, what is the particular z value, that will be given by PPF. Okay, let me share it with you quickly. So, here is a link to my YouTube channel. You can go and look back at the previous recordings, previous session recordings. Okay. So, is this particular thing clear to everyone? What is PPF and what is CDF?
Can you explain another time?
Okay, cool. So,
PPF is actually a single, like for an example, an exact value, right?
exact value till which that particular area will be there under the curve.
Okay, okay. So what is the difference in PPF and PDF?
PDF is the exact value at that particular. So, given this z value, the PDF will be
Yeah.
the value of the curve over here. This particular value.
Okay, okay.
Yeah. And PPF is
The thing is that while using Python, the main thing I tend to do is that I get confused between what to do, .pdf or .ppf. So that's the
okay.
main thing.
So, in PPF, you will have to see the input. In PDF, sorry. So, PDF is probability density function. So, in that you get given the z value, you find the value of the value on the curve, on the normal distribution curve. Okay. In the case of PPF, you are giving the area under the curve as input. This is z value given as input, and this is area under the curve given as input. So,
Can you speak this? Sorry, sir. Can you speak this line one more time? PDF and PPF.
Okay, PDF. Let me just show you the PDF and PPF over here in Python. stats.norm.pdf sorry of 0, say it is 0.3989, which is nothing but this particular value over here. If you see the normal distribution, so for 0, if you see the value over here, it is like 0.39 somewhat over here. Let us see the value of 1. stats.norm.pdf 1, it is 0.24, and which is approximately 0.24 over here in this case. So, what PDF does is, given the value, what will be the corresponding y value or the probability density. So, these y values are called probability densities. Area under the curve is the probability that you have. Okay. So, PDF gives you the probability density corresponding to a particular z value or whatever random variable. If it is any sort of normal distribution, this is standard normal distribution, but it can have any like normal distribution can have any mean value or any standard deviation value. Based on that, it will give you the corresponding probability density. Is that clear what PDF does? Nikhil and
Yes, sir.
Sandeep, yeah. Nikhil, is it
Yeah,
clear?
actually, the main thing is that it will be better understandable if I think so. If there's two examples, one mentioning the PDF and one is asking about the PPF.
One mentioning PDF, like example in the sense like you mean
Question. Basically, a question. that asks about the PDF, and another question that essentially asks about PPF only.
Okay, like so in this case, in the hypothesis testing, we'll be mostly dealing with CDF and PPF.
Okay.
PDF is not generally taken into account in the hypothesis testing, but yeah, we'll definitely look into it later.
Yeah, sure.
Yeah, so PDF is basically given the particular random variable value, what will be the corresponding probability density. In the case of binomial distribution and other things, you have this PMF. So in this case, the y value is probability. Okay, so for random variable value 0, 1, 2, 3, 4, 5, the PMF will be the probability value. But in the case of continuous distribution, you don't have the concept of probability mass function. In that, you have the concept of probability density function. So correspond as similar to probability mass function in the case of discrete distribution, you have probability density function in the case of continuous distributions. So here it is PMF, and there that is PDF. Okay, so stats.norm.pdf will give you the corresponding y-axis value or the probability density value given the z value. Stats.norm.cdf will give you the area under the curve till that particular z value. So in this case it is 0, so it will give you this particular area under the curve till 0, that is cumulative distribution function. Then stats.norm. Now given this area, like say I have this area under the curve, say this orange color, this dark orange color is given to me, the value. So to find out the corresponding z value over there, I use PPF function. So in the case of PPF function, the input is area under the curve and the output is the corresponding z value. In case of PDF and PDF and CDF, the value is z value. PDF gives you the exact value at that particular point, and CDF will give you the area under the curve. Is it clear to you, Nikhil?
Yeah.
Okay. Let us see the examples. At least PPF and CDF will be clear to you after this. Okay. So stats.norm.alpha .ppf alpha. So here in this case, let me again go back to iPad. So I have z distribution. If alpha is given to me, I want to find what is the corresponding z over here. So how will I do that? Given the value of alpha, how will you find this z value?
Sir, alpha is the area here?
Yeah, alpha is the area here. This area, so area under the curve for any probability density function will be the probability value. And in the case of hypothesis testing, the z distribution, this area under the curve alpha, which is taken as 0.05 generally, it represents the probability of rejecting the null hypothesis. So what we were having, say the null hypothesis is that the mean of certain thing is 30 and you are taking a sample from the population and you found that the mean is say 500, which is very unusual. So the probability, so there are two possibilities, either this is true and it is rarely occurring as can be seen from this value. So corresponding y value over here if you see is very low, or you are making a mistake. Two possibilities are there, either this is true and rare, or second thing, it's a mistake or error. Fine. So what you do is you try to find the probability. Let me make this over here. Say 500 is over here somewhere, just ignore the scale. So you try to find the probability of occurrence of events in which mean will be greater than or equal to 500. If this probability is less than alpha, then you say that your null hypothesis has been rejected. Okay, this is one tail test. Is this criterion clear? Like, so this is like the space of x bar and we are transferring it to z space where it is easy to compute area under the curve because you have this z table, right? So we saw in the very beginning like how we can shift this normal distribution to some other space. So the moment you do x minus mu upon sigma by root n, this particular distribution of sample means is having mean mu and standard deviation of sigma by root n. And then when you are converting it to z, this z distribution is having the mean of 0 and standard deviation of 1. So now the values are pre-computed for this. So you have this z table. Okay, Priyanshu, you did not understand that. What is it that you did not understand? I'll re-explain. Please let me know. If there are any queries, please let me know.
Sir, actually, जैसे when p value is less, then we reject the null hypothesis. But when you were explaining in the diagram, I was not getting the concept why we have to reject. So can you please re-explain this?
Okay, just a second, Bhumi. I'll do that. Okay, so here are some material that I have added to the slides. So what is your p-value? So p-value is the probability computed using the test statistic that measures the support that measures the support or lack of support provided by the sample for the null hypothesis. Okay, so when you are computing area under the curve for a given sample statistic, did you get the point till like how we compute z? What exactly we are doing by computing the z value, that is x bar minus mu by sigma by root n. Bhumi, is that clear to you?
Yes, sir, that is clear.
Okay. So you have mean of the sample, distribution of the sample means. You are having the values over here. The sample statistics is given to you.
So
Now,
should we use only sigma, x bar mu by sigma for this?
no. So in this case, Nikhil, sigma by root n is the mean of the standard deviation of the distribution of sample mean. It is not sigma. Sigma is the standard deviation of the population, the actual population.
Okay.
Okay, but when you take samples out of the population and plot the distribution of the means of those samples, so that particular distribution will have this standard deviation of sigma by root n. So
So it's just population, like this is the metric for population and that is the metric for sample.
the distribution of sample means. So what do we mean by distribution of sample mean? In the last class we saw, right, like we were taking sample, computing mean of that and plotting it. Okay,
Okay.
for every sample you take, you compute the mean and plot it, and so on. So you kind of like end up getting a distribution of sample mean, and that distribution is having the mean same as the population mean, but the standard deviation of this particular distribution will be sigma by root n. Now how it is derived, that is that derivation maybe we will discuss in the next class, or I will just point you out to that derivation. I will put the link to that in the video YouTube video description. Okay, so this,
So technically, how do you define Z in terms of a technical term?
okay, so Z is nothing but you are transferring this distribution to a standard normal distribution, transforming this particular distribution of sample means to a standard normal distribution. So this particular mean will get shifted to mean 0. You are making the standard deviation of this particular distribution as 1. So now every value, so every statistic that you compute, say x bar is over here, so this x bar will get shifted to z over here in this z distribution space, and that z is computed using x bar minus mu divided by sigma by root n. So once you have this z value, it is easy to compute the area under the curve, because the integration will be easy over here, like, and you have the z table already available with you. Okay, so that's the major reason that we convert this particular sample statistic to this test statistic, that is z, and then using that we compute the area under the curve. Here we could have directly computed the area under the curve for x, but since we already have this pre-computed area in z table, we transform it to the z space and do all this computation over there. And all this libraries in Python and like stats.norm, it also considers the standard normal distribution, that is z, with mean 0 and standard deviation 1. So basically you are transforming the distribution of sample means, which is nothing but this this thing, highlighted thing, to standard normal distribution with mean 0 and standard deviation 1. The only reason is the way you are computing the area under the curve. Okay, Sandeep, is that clear to you?
Yes, sir.
Okay. Nikhil, any query in this? Anyone having any query?
Sir, you can proceed.
Okay, thank you. So there are, so as I said, there were, depending on the nature of the null hypothesis or an alternate hypothesis, you will have three kinds of tests. One is upper tail test, in which you will consider the alpha, that is the probability of rejecting a null hypothesis, concentrated on the upper tail. In the lower tail test, you will have this alpha concentrated towards the lower tail, and then in the two tail test, you will have alpha distributed over the two tails, alpha by 2 over here and alpha by 2 over here. Say the alternate hypothesis is something like mean greater than equal to 30. Okay. So in that case, you will be using upper tail test. If it is like this, you will, or in general anything mu naught, you, in that case you will be using the lower tail test. And if it is both, if the null hypothesis is mean equal to mu naught, so in that case alternate hypothesis will be mean greater than mu naught or mean less than mu naught. So in that case you will be using this two tail test, in which alpha, that is the probability of rejecting the null hypothesis, is distributed over the two tails. Okay. And that is nothing but your type 1 error. Fine. So what you are doing right now is you are computing the z value. Say z value, whatever z value you have computed, if it lies over here, so the area under the curve will be more than alpha. Now if it is more than alpha, in that case you fail to reject the null hypothesis. If it is less than alpha, then you reject the null hypothesis. Similarly,
Can you just please repeat the statement?
okay, whatever, so you have this z distribution, you have the alpha defined, right? That is the significance level. Till this point it is clear, right? Now given the
Yes.
now given the sample statistic, the number of like the sample size, the population standard deviation and the population mean, you can compute this z value as x bar minus mu upon sigma by root n, and then this z value might lie anywhere on this axis. Okay. So if this z value is lying over here, so the area under the curve, this blue area, is known as p value. It says that probability that z is greater than equal to, say this is z naught, z naught. So this represents the probability that the value of z is greater than equal to z naught, and this is the p value. If p value is greater than alpha, in that case you fail to reject null hypothesis. And if it is less than alpha, you reject null hypothesis. This is for one tail test. Is this clear? Shanku?
Yes. Thank you, Sash.
Yeah. So this z value can be over here as well. So this green color. So this is known as p value approach for hypothesis testing, in which you compute the z and you get the corresponding area, and you compare that area with this alpha, which is also nothing but area under the curve. So if this particular p value is greater than alpha, greater than equal to alpha, you fail to reject the null hypothesis. And if it is less than alpha, then you say that we have statistically significant evidences to reject the null hypothesis, and you reject the null hypothesis accordingly. Similarly, if it were the case like on the other end, you have alpha over here. If my z lies somewhere over here, the computed z lies over here. So, area under the curve will be this. So, this area is less than my alpha. So, I reject my null hypothesis. This is p-value approach. Now, what is critical value approach? So, you have this z naught computed, right, using the sample statistic. Now, for this alpha, there will be corresponding z alpha. So, the area under the curve after this z alpha will be alpha. So, based on the position of this z naught, you can see if null hypothesis is getting rejected or not. So, if z naught is less than z alpha, then you fail to reject null hypothesis. If z naught is somewhere after z alpha, then you reject null hypothesis. It's as simple as that. Similarly, in the case of this, you have this z alpha. If z is like z naught is less than z alpha, you reject null hypothesis. If it is greater than z alpha, you fail to reject null hypothesis. And if it is two-tailed test, in that case you will have to be pretty careful. Here, please everyone, please make sure that you are on mute. So, here your alpha is distributed over the two tails. So, the z value that you will be getting will be either over here or here. So, based on that, you will have to compute the area under the curve, that is p value, and compare it with alpha by 2, or you can compute the corresponding z value for this alpha by 2 area under the curve and compare it with the computed z statistic. So, based on that, you can make decision whether to reject null hypothesis or not. Okay. So, now coming back to our question of pizza delivery, let us go back to Python.
Sir, can you please explain the two-tailed test with the help of an example?
Yeah, we have an example in Python, so we will see that.
Okay.
Yeah. So, the mean response time for a random sample of 30 pizza delivery is 32 minutes. The population standard deviation is believed to be 10 minutes. The pizza delivery services director wants to perform a hypothesis test with alpha equal to 0.05 level of significance to determine whether the service goal of 30 minutes or less is being achieved. Okay. So, solve using p-value approach and the critical value approach. So, what are the values given to us? Mean is given as 30, population standard deviation is given as 10 minutes, sample size is of 30, sample statistics, that is sample mean, is given to be 32 minutes, and significance level alpha is given as 0.05. Now, here the null hypothesis will be the mean response time is less than equal to 30, h naught is mu less than equal to 30. So, the alternate hypothesis will be mu greater than 30. Okay. I am just importing this NumPy library over here to use the square root function. So, first step will be to compute the z statistic. How we are going to compute that? X bar minus mu divided by sigma by square root of n. Okay. So, let me just print this value. Oops, I have to run this. Okay. So, I have got some z value. This z value will be lying somewhere over here. So if you go and see the normal distribution, it will be around like, so what was the z value over here? 1.09. So it will be somewhere over here, 1.09. So what will be the p value, the area under the curve till this 1.09? So it will be 1 minus CDF of this particular distribution till 1.09. Is that clear? Area under the curve after 1.09 will be 1 minus area till this particular point. Okay, let me explain it to you. I have this function distribution. I want to find, so this is my z value. In this case it was around 1.09 something. I want to find this area under the curve, which is nothing but my p value. So how will you find that? Bhumi, can you answer?
Sir, 1 minus this.
So what is that particular thing?
So that area, that p value.
Stats.norm of CDF.
Okay, so 1 minus CDF of z, right? And CDF of z is nothing but this red color area. And in Python, you do it using stats.norm module. So let us go back to Python. So if it were like this, so it will be directly, this area will be, your z is over here, this will be CDF of z. But in this case we want to find this particular area. So it will be 1 minus CDF of z. Is that clear, Bhumi?
Yes, sir.
Okay. Fine. So here I am computing p value as 1 minus stats.norm.cdf, and let us print the p value. So you can see that the p value or the area under the curve after this 1.09 is 0.13, which is greater than the alpha value 0.05. So we fail to reject the null hypothesis because there are not statistically significant evidences or sufficient statistical evidences to reject the null hypothesis. So what are the steps we computed, like we have done? First of all, see the data and identify the parameters given. In this case we were given this mean, population standard deviation, sample size, sample mean and the significance level. Now we have to define the null and the alternate hypothesis. So in this case null hypothesis was mean less than equal to 30.
Hello Shesh, my question is that why the null hypothesis says that mu is less than or equal to 30?
Yeah, so here in this case it depends on the problem at hand. So this was the case of pizza deliveries. So generally, like in pizza delivery system, if the mean delivery time, if the delivery time is less than or equal to 30 minutes, you will be getting you will have to pay for that particular delivery. If it is beyond 30 minutes, then it will be free of cost. So what they were trying to do is they had taken the sample of certain pizza deliveries and they found that it was 32 minutes. The mean of that particular delivery times was 32 minutes, and the service director was like he wanted to know, perform this hypothesis test that if it is significant, if this particular observation that they are getting from the sample, is it significant or not? So for that particular case, we are having, so depending on the problem at hand, we are having this null hypothesis as the mean delivery time is less than equal to 30. You can anyway define it as mean equal to 30 as well, and what you are interested in the alternate hypothesis is mean greater than 30 in this case. But if it were like you wanted to know if it is exactly 30 or not, so in that case you will have to use two-tail test. Is that clear?
Yes, yes. Thank you.
Yeah. So it was based on the problem. The
Sir, one question. Simple question.
Yes.
Sir, previous to this, you have written mu is less than equals to 30.
Yeah, yeah.
Is it called upper limit test? In the previous case, what you had written just now.
Yes.
You edited this.
So upper tail test, not upper limit test. It is known as upper tail test. So in this case, your alternate hypothesis is mu greater than equal to 30. So the moment you see this greater than sign in the alternate hypothesis, it means that you will have to do upper tail test. If it were like this, mean less than 13 alternate hypothesis, then you will be going for the lower tail test. And if it is strictly
So equal to means a two-tail test, right?
Yeah. So if it is strictly not equal to 30, it implies that mean is either greater than 30 or mean less than 30. So in this case, you go for two-tail test.
And Saish, another doubt is that can you actually also explain this question statistically as well? After printing Z using the formula, can you explain the process statistically? Like what do you do after that? Like bringing in the alpha and things like that. Like how do you move?
Okay. So did you get this point? Like given this data, you are computing Z value, right?
Yeah.
Yeah. Using this Z value, you are computing P value, which is nothing but probability
Okay.
of observing this, probability of getting values greater than equal to Z.
Okay.
Okay.
So Z as like you have created two intervals like using the Z table. Statistically, I'm speaking. Now we have with the help of the alpha, the significance level, we have took the alpha in the Z, like distribution table. For an example, for 0.05, the distribution table like value is 1.96. So similar to that, you also take a value for Z as well. You create an interval and you compute with the help of that. Is it right?
Oh, you mean like confidence interval based?
Statistically. Yeah. I'm talking about, yeah.
Yeah, what we are doing is also statistics actually. What
Yeah.
you are saying is, I think if I get it correctly, you are trying to say if we can use confidence interval based method over here.
Yeah.
Okay, I see. Okay, let us see that. So, okay, I'll come to that. I have an example in which we'll be discussing that confidence interval based method to identify if we can.
So what method are you using here? Or like,
so see, this is the moment you calculate Z and the p-value. So depending on the p-value and alpha, you are making a decision whether to reject null hypothesis or not. This is the p-value approach. Okay.
Okay.
But if you compute the
yes, because like we will not be able to have, for an example, if this comes in the exam point of view, if you are about to calculate through this method, so how will we be able to do it on paper? Like that's why that's what I meant.
For that you will be, so you can compute Z value using pen and paper, right? Like you will be given certain values with which you will be computing Z value. Now once you have this Z value, you can go to Z table. Okay, let me just go to Z table. So this Z table will be given to you as one of the persons mentioned. So this Z table will give you the area under the curve like the CDF value.
Yeah.
Okay.
Yeah.
Let me just zoom in. Okay. So once you have 1.09, so you go over here 1.09.
Yeah.
So you will get the area under the curve till that particular point.
Okay.
Okay.
Yeah.
But in this case, wait a second. Yeah. So you have been given 1.09, right? So let us see what this stats.norm.cdf does. So it is 0.8633, and if you see the value in the Z table, 1.09, 0.86, it's pretty much close to what we are getting over here.
Okay.
Is it clear?
Yeah, we should find first the z value using the formula, and
And then
the z value should go into the distribution table and find the uh,
corresponding the
corresponding.
CDF, corresponding CDF.
Yeah,
And now depending on the nature of the tail test what you are using, if you are using the lower tail test, so
z should be less than p.
no, your CDF itself will be the p value,
Okay,
because that is the area under the curve that you are looking for. But if it is upper tail test,
okay,
what you are looking at is
okay,
this area under the curve, so it will be 1 minus
okay,
CDF.
So
okay.
to decide about which tail test you have to take,
Yeah.
if the hypotheses are given, then you have to look for the alternative hypothesis to decide about which
Yes.
tail test you
Yes.
have to take.
Yes. Yes. Exactly.
Okay, it's not from the null hypothesis, I guess.
So null hypothesis actually defines the alternate
If it is
hypothesis.
equal to, then no. If null hypothesis is equal to, then in that case you have to take two tail tests directly, or you have to
No,
look
no,
for
no. It depends on the alternate hypothesis as well.
alternative.
Yeah, yeah, yeah.
Okay, okay.
So if the null hypothesis it's like equal to 30, and then you are just interested in seeing like mu is greater than 30 or not. So
Then upper tail.
then upper tail test. Generally, people write this equality sign only over here, but in this case, it was implicit that it is less than equal to. But
Okay. In
yeah,
that case, it is very clear.
yeah. So the
Hmm.
alternate hypothesis over
So
here.
what's the criteria actually? What's the criteria for the upper tail else for p value should be greater than z or something related to that?
Yeah. So in the case
What's
of
the
upper tail test, so if
for acceptance and rejection
yeah,
basically?
so if p value is greater than alpha, then it means that you are failing to reject the null hypothesis. If p value is less than alpha, then you are rejecting the null hypothesis. Okay, let me just show it to you on iPad. You have this distribution, you get the z value, fine. Now you compute the area under the curve. This is your p value. Now if this p value is greater than alpha, this red color area is alpha. For the upper tail test, if it is greater than alpha, then you are failing to reject the null hypothesis. Whereas if this is the case, you are computing p value for a given z, and if it is less than alpha, you reject the null hypothesis. Is that clear, Nikhil?
Yeah, sure. So the acceptance region is towards the right of the z.
Yeah, accept that we yeah, that is called as acceptance region, but also like many people avoid to say it as acceptance. They say that you fail to reject null hypothesis.
Okay, okay, okay.
Okay, so
Sure.
this particular region, it is totally acceptable. Okay, let me just show you. In the case of upper tail test, this entire region will be where you are accepting the null hypothesis, but researchers generally tend to use this term fail to reject null hypothesis, because they say we don't have significant evidences to reject the null hypothesis. But if you are getting certain evidence based on which you are having certain p value which is falling under this rejection region, so you are rejecting the null hypothesis.
Actually, initially you said the other way around, I guess.
Oh, is it like if
Yeah,
oh
Yes.
yeah, you.
sorry, no, sorry, this particular region is the rejection region, not that, based on the
Okay,
alpha. Yeah, thank you for pointing
okay,
that out.
sure.
Yeah,
Got confused.
Yeah.
yeah.
Actually, if you make it like from the beginning, from the top of this, it would be helpful.
Okay, fine. So you have this alpha. So let us see only at alpha. So
Yeah,
for this alpha, you will be having certain z alpha value, right?
Yes.
yeah,
So this z alpha is known as critical boundary or critical value.
yes.
So if your z lies after this, then you are rejecting the null hypothesis. Reject. If it is
Okay,
the,
okay,
so do not reject.
okay. Now it's clear.
Yeah. So nothing but
So
like
the p-value, so if you
this.
are finding a p-value, for an example, alpha and z alpha is there,
Yeah.
and after finding alpha, after computing z, you find the corresponding p-value as well.
So p
So if
value.
the p-value
Yeah.
lies in the rejection region, you reject. If does not, if it does not lies in there, you do not reject.
Yes. So if your z is
Okay.
lying over here, so definitely the area
Yeah.
under the curve will be less than alpha, right?
Yeah.
Yeah. So your p value will be less than alpha. So in that case, you are rejecting the null hypothesis. It's actually the same thing being looked from different perspective. In one thing, you are just comparing the z values, z alpha and the computed z value. In the other case, you are comparing the probabilities, that is area under the curve, corresponding to these z values.
Sure.
Is
Sure,
it
size.
is it clear, Sandeep?
Yes.
Yeah. So in this was the case of upper tail test. Okay. So let us move back to that question, and then we will see how to do that using critical value approach. So here you were having this z computed, right? It was 1.09. Now, if you want to compute z alpha, that is the z value corresponding to the region alpha, like the area under the curve alpha on the upper side part. So it will be ppf of 1 minus alpha. For example, this white color region. If you want to find the z value corresponding to this white color region, you will have to find the ppf for this particular area under the curve. This area under the curve is this particular white area under the curve. So how will you find this particular thing? Z, it will be ppf of this particular area. So if you know this area, you can find this area, right? And the ppf corresponding to this area will be this particular z. Is it clear, everyone? Nikhil, Sandeep, others?
See, can't we use stats.norm.cdf 1 minus
Yes.
stats.norm.cdf?
Yeah, that's through Python, but this is actually statistically you just explained this.
Okay. Okay. Got it.
No, CDF will give you the area under the curve. Sorry. Okay, so once you have this area under the curve, but what we are trying to do is for the corresponding alpha, like alpha is given to us, we are trying to find out z alpha. Okay, alpha is given to us and we are trying to find the corresponding z alpha. For that, we are trying to find this area under the curve, which is nothing but 1 minus alpha, and for 1 minus alpha, this is the corresponding z alpha. So that's what we are finding over here. Stats.norm of ppf 1 minus alpha. The z, what you are saying is 1 minus stats.norm of cdf dot z. So this z is already with us. We don't have to compute that. So if you just see over here, let me just print it. Z is 1.79, and if I
0.
print
Okay.
stats dot norm dot 1 minus stats dot norm dot CDF of so do you see this is nothing but the p value.
Okay.
Yeah, so this Z is already with us. We need not compute it, it's like indirectly computing the same thing. Okay, so the Z's are already with us. What we wanted to compute is the Z value corresponding to that alpha region, like area under the curve. So for that you are using this stats.norm.ppf 1 minus alpha. So you have this 1.64 as the value. Now you compare it with the Z value. So Z value is 1.09 and the Z alpha value is 1.64. So Z is less than Z alpha, which is like not in the rejection region. So hence you fail to reject the null hypothesis or do not reject the null hypothesis. Is this clear?
So what is the conclusion? That the pizza will be delivered in less than 30 minutes. It means like this?
No, you fail that. You don't have the sufficient number of evidences that it won't be delivered in, it will be delivered in 30 minutes. So
in the both the cases you are saying we do not reject.
we do not reject it. We do not reject the null hypothesis. We don't know if it is true or not.
Okay.
Yeah, but if it is beyond this Z alpha, then we definitely say that we can reject the null hypothesis given the significance level alpha.
Okay.
Is it clear?
Can you please go to the question? I
Yeah.
just want to ask the significance of particular line.
Yeah.
Okay, yes. There's one statement called as the population standard deviation is believed to be 10 minutes.
Yes.
What is the significance of it in terms of pizza delivery and pizza order? What does it mean?
Okay. So you have pizza deliveries, right? So you have a distribution fitted over the pizza delivery times. Your random variable is pizza delivery time. Fine. So if you fit the distribution over this pizza delivery time, the actual pizza delivery time that are happening around the world, or like for that particular pizza shop, so the distribution will have the distribution will be normal distribution that is having a standard deviation of 10 minutes.
Sir, my question is in real time scenario, what does this 10 minutes mean? Does it mean plus minus 10?
Standard deviation, it says the dispersion in the distribution. So the shape of the distribution, okay, I will request you to go back to the very first lectures, like first and second lecture in which we discuss dispersion.
Okay.
So standard deviation, okay, let me just show you normal distributions. So if you see this curve, this particular red curve is having standard like variance of 1. Standard deviation is
Yes.
nothing but under root of variance.
Variance.
Yeah, if you see this curve which is having this variance of 0.5, so if you like the spread of this particular distribution is less compared to this, right? And if you see for this which is having this variance of 0.2, it is even it is further less than that. So this standard deviation shows the deviation from the mean. So this is the mean of this distribution, and it shows how much spread there is with respect to the mean. So if you are, so suppose this x-axis represents the delivery times. So my mean delivery time is 30 minutes, and then how much deviation I have from the 30-minute mean delivery time. I can deliver plus minus, like as you said, plus minus
10.
so one standard deviation plus minus will be like a certain interval that you are giving. So but we'll come out to the confidence interval part later, in which we will see like how to estimate the confidence interval for a given population parameter.
Sir, in this particular graph, I could understand sigma square. What is the mu? What is mu? What do you relate to it?
Mu is nothing but the mean of the distribution.
Okay. Thank you.
Yeah. Okay, so this one problem was on solving the like doing hypothesis testing using p-value and critical value approach. Let us quickly see this one and then we'll stop. Assume that a sample of 30 milk carton provides a sample mean of 505 ml. The population standard deviation is believed to be 10 ml. Perform a hypothesis test at the 0.03 level of significance. Population mean 500 ml, and to help determine whether the filling process should continue operating or be stopped and corrected. So can you understand the scenario over here? Like, did you understand the question, what is happening in this? Let me put it in chat. Reread this question. Assume that a sample of 30 ml carton provides a sample mean of 505 ml. The population standard deviation is believed to be 10 ml. Perform a hypothesis test at 0.03 level of significance. Okay, so let us see the data first. What is given to us? Population mean is given as 500. Population standard deviation is given as 10. The sample size is given as 30 milk cartons, and 30 milk cartons were taken, and the mean amount of milk in this 30 milk cartons was 505, that is x bar, and significance level is given as alpha. Okay, so in this case my null hypothesis is every carton is having on an average 500 ml of milk in them, and the alternate hypothesis will be less than equal to, because on seeing the nature of this problem, we don't want to have less amount of milk or more amount of milk in the cartons. We want it exactly to be around 500 ml. So my null hypothesis is the amount of milk, mean amount of milk is 500, and it is not 500. If it is more than that, it means that there is some problem. More than or less than, then there is some problem in the production and it needs to be stopped. Okay, so first step is to compute the z value, x bar minus mu upon sigma by square root of n. So what is the nature of the test that we will be using over here? Upper tail, lower tail, or two tail?
It's a two-tail.
Two-tail.
Yeah, so it will be two tail test in this case. So whatever z value we are getting, it is 2.73. Now let me go back to iPad and explain this quickly. The z value that we have got is 2.73 or something like that. Yeah. But since this is a two-tail test problem, we will be considering this area as well as this area to compute our p value. So, the combined area, which is nothing but 2 times this particular area, is our p value. So, now if this p value is greater than alpha, we fail to reject null hypothesis. We reject null hypothesis. Is it clear?
Yes. Yeah.
So, for you will have to keep it in mind, for 2-TEL test you will be getting either this z or this z depending on the sample statistic x bar. So, you will have to compute that area and then consider the other symmetric area as well to compute the overall p value. The other way is to compute only one area and then compare it with alpha by 2. So, in the case of 2-TEL test, the significance level alpha is distributed over the 2 TELs. So, this will be alpha by 2 and this will be alpha by 2. So, based on the alpha by 2 value, you can either reject or accept the null hypothesis, fail to reject the null hypothesis. Similarly, you can compute the z alpha by 2 over here, that will be your critical region. So, if the z value is less than z alpha by 2 or greater than z alpha by 2, based on that you will reject, or so if it is greater than z alpha by 2 you will reject the null hypothesis. If it is less than this, you will fail to reject the null hypothesis. So, in this case, this region between z alpha by 2 and negative z alpha by negative alpha by 2, negative of z alpha by 2 will be your acceptance region and this will be your rejection region. Is it clear, everyone?
Yeah.
What about the others? Is it clear to everyone?
Yes.
Okay.
Sir, one last time. Sir, if Z alpha is greater than the Z value, then we have to reject, or we are failed to reject null hypothesis.
If alpha is greater, means the area under the
If
curve
Z
is,
alpha,
yeah,
if Z alpha,
z alpha, okay, z alpha by 2, if it is greater than z, then we
yes.
reject the null hypothesis.
Sir, but in the last question that we have solved, in that we have it was written Z alpha is greater than the Z value, then we are failed to reject null
No. It was
hypothesis.
not z value, it was p value. So, p value is nothing but the area under the curve. So, if you see, okay, let me zoom this in. So, we are just seeing the tail, okay, this is the tail. So, if my z is over here, so the area under the curve will be my p value, and if alpha is like area under the curve is this alpha, here my p value is less than alpha, right? This
Yes, sir.
red thing is alpha. So, in this case p value is less than alpha and this is the z alpha, okay. So, z alpha is greater than z. Now, is it clear to you?
Yes, sir.
Yeah. So in this case we are looking at the area under the curve, and in this case you are looking at the z values, the x-axis values. That's the only difference. So the first approach is called as p-value approach, and this approach is the critical value approach. Okay. Okay. So in this case you are finding z, then for that particular z you are computing the area under the curve depending on the value of z. So in this case the z value was positive, so you will be taking 1 minus stats dot norm dot cdf of z, and then I am taking twice of that since it is a two-tailed test. So that will be my p value. So this p value, whatever I am getting, it is less than alpha. My alpha value is 0.03. So in this case it is less than alpha, so we reject the null hypothesis. It means that the mean amount of milk being filled in the cartons is not 500 ml. So the filling process needs to be stopped. This was p value approach. If you want to do it using critical value approach, you can find out z alpha by 2. So how you do that? Z alpha by 2 will be stats dot norm dot ppf, and what will you give over here? 1 minus alpha by 2. So this is 2.17. What we were doing is z alpha by 2, so we are assuming that alpha by 2 is spread over here, alpha by 2, another alpha by 2 is on the left side of the tail, so left tail, and alpha by 2 is on the right tail. So we are finding the z alpha corresponding to that alpha by 2 and comparing it with the z value that we have got. So the z value that we have got is 2.73, which is more than 2.17. So we reject the null hypothesis. So you will have to be careful. In critical value approach, you are computing the z values, and in the p value approach you are computing the area under the curve, that is p value with respect to alpha. Is it clear to everyone?
So in the last line, line number 37, you are computing z alpha by 2 is equals to stats.tom.ppf.
Yes.
So do we need to multiply this z alpha by 2 by multiplied by 2 to find out the exact value of z alpha?
Not needed. What you are computing here, okay, let me go back to so this is my distribution, and I have this alpha by 2 over here and alpha by 2 over here, right?
Yeah.
So this particular value will be z alpha by 2, and this
Yes.
particular value will be negative z alpha by 2. So you just need this particular area.
Okay, we need not to multiply it by 2 to find out the total area.
No, you don't need. So what ppf does is it takes this area into consideration. So 1 minus z alpha by 2 will be this entire green region.
Okay. Entire green region,
Yeah.
including the left
Yeah.
minus z alpha by 2.
Yeah.
Okay.
So it will be like till here. So
Okay.
you are passing out this area, and then you're finding this z alpha by 2.
Okay. Okay, got it, sir.
Okay. Fine. So you got some z alpha by 2 value and you're comparing it with the z value computed, and then based on that you are rejecting the null hypothesis. Now this is the, okay, I have already have this over here written, same thing. Okay, now this is the confidence interval approach. So what you are doing over here, again let me go back to iPad and then we'll stop. We'll see this problem in the next class. So what confidence interval says is, if my population parameter lies within this range, plus minus, then I'll accept the null hypothesis. If it is not the case, then I'll reject the null hypothesis. Now we have this x with us, we have sigma with us, we have n with us. The only thing that we have to compute is z. So how will you compute z for a given value of alpha? That we know, right? So given the alpha, we can compute this z alpha. So let us go back to Python. So confidence interval will be x bar minus z alpha by 2. In this case, since it was 2-tailed test, we are having this z alpha by 2 into sigma by root n and x bar plus z alpha by 2 sigma by root n. So the confidence interval that you are getting over here is phi naught 1 to phi naught 8, but our mean was 500, which is not lying in this range. So we reject the null hypothesis.
Sir, there is one doubt. Why are you using z alpha by 2?
Yeah, so this is, since this is 2-tailed test, we are the alpha value is spread over the 2 tails. That's why we are taking this z alpha by 2 into consideration.
Yeah.
Yeah. So it depends on the nature of the test that you are doing.
Carry on, please.
Okay. Okay. So yeah, we'll look into the other problem maybe later. So this one example was given, which deals with t-test. So we'll do this t-test analysis in the next class maybe. And I'm very sorry that we are running late, but I feel that going slow will only make you understand things. If I keep on just covering the concepts, many of you may not be able to grasp the things that easily. So yeah, please if you want to cover like advanced concepts, there are tutorials available online. If you feel that these lectures are very basic, so please feel free to look at those other tutorials. There are many tutorials by one is by JB Statistics and Khan Academy and 3Blue1Pro. There are many other channels which provide tutorials on statistics, even the advanced concepts. So please look into that. And you can also join the problem solving sessions provided by other TAs, being taken by other TAs. One is on Saturday and 2 are on Tuesdays. So they might also cover certain advanced concepts. So you may join those sessions as well. if you feel these sessions are quite basic, but yeah, I want to keep it at basic level for the majority of the audience to understand, like who are finding it difficult to grasp even the basic concepts of the course. So yeah, and I hope this session was useful, and apologies for any confusions I would have created in between. So yeah, you can let me know your feedback on what needs to be improved and the mistakes I would have made in the session.
No, no, it was too basic. It is good for us because I don't know the basics also. So it is anyway very good for me.
Yeah,
Thank you.
thank you for that feedback. And others also, please let me know, like if you have any other feedback, like if you want me to cover any other topic specifically, I'll try to prepare some material for that in the next session. Niva, you have any query?
No, no, no. Thank you so much.
Okay, thank you.
Thanks for the session.
Thank you. Thank you. Okay, thank you everyone for joining. I'll end the session then.
Thank you very much, sir.
Thank you, Bhumi.